here you go. Distribution of electrons for first 20 elements. That's what I'm going to show you here real quick. And also you can say distribution, or you can say the electron configuration for first 20 elements. And then you're also going to learn how to draw Bohr models. Okay. Remember, we are just focusing on first 20 elements, atomic number 1 through 20. Okay, so let's start with an example. You need a periodic table, students, so make sure you have a periodic table with you. Locate on your periodic table, locate magnesium, and you're going to see atomic number at the top, and then atomic mass is given at the bottom. So this one is the atomic number, this one atomic mass. You round it off, and when you round it off, and the rounded off atomic mass, you call it the mass number. And you know the rules for rounding off. This is 24, just because it's 0.3 after the decimal. Okay, and the atomic number is 12. How would you determine the number of protons, neutrons, and electrons? So number of protons is equals to number of electrons for neutral atoms. So in this case also this one is equals to the number of protons. So atomic number is same as number of protons. So here we have number of protons 12, number of electrons 12. And how do you determine neutrons? Neutrons is mass number minus, this is minus atomic number. All right, so the neutrons and protons are located inside the nucleus. When you draw the Bohr models, you can show them there, but we are going to focus more on electrons, mainly because our main learning at this time is about showing the electron configuration or the distribution of electrons in the shells which are outside the nucleus. So in this case you have 24 and then minus 12, which will give you 12. So you have 12 neutrons. All right, so here let's start drawing the Bohr model for this one. Here there is a rule called 2-8-8-18 rule. Now please make sure that you are following this rule of 2-8-8-18 rule only for first 20 elements, because after atomic number 20 it gets trickier, and that we are going to discuss that in another video. So this one, the first shell, is called the K shell, this one is the L, this one the M, and this one N shell. K is the innermost shell, and this innermost shell can accommodate only 2 electrons, maximum 2 electrons, not more than 2. This one is the second shell, and this can accommodate maximum 8 electrons, and then you move on. Let's draw the Bohr model for this one. In the center you're going to draw nucleus, and for magnesium we said how many electrons? 12 electrons. So it is 12 electrons. Let's follow this rule and then divide it in the first shell to maximum. All right, now we need another shell, 8, so 2 plus 8 is 10, but we have to go until 12. So 2, 8, and 2. Now it is all together 12 electrons. Draw the first shell, second shell, and the third shell. There you go. So 2 electrons here. Let me write with this one. 2, 8, and 2. This is shell K, L, and M. Alright, so that's how you draw Bohr models. Now, Let me ask you a question. Could it be 2, 9, 1? Because 2 plus 9 plus 1 is still 12. Yes? No? No. Because the reason is you can't, or the rule says you can't put more than 8 electrons in the second shell. But this here you have 9. So this one is incorrect. How about 1, 8, and 3? This is still 12. Can you do that? Again, you can't, because before you go, so previous shell should be completely filled before adding electrons to the next shell. Okay, so we have to keep that rule in mind, that previous shells need to be completely filled before you add electrons in the next shell. All right, so let's do one more example. Let me underline, highlight all this. This is protons equals to electrons for neutral atoms. How do you find the neutrons? Neutrons is right here. You would show neutrons and protons inside the nucleus. Okay, and this is K shell, the innermost. This one is the second shell, can have maximum 8 electrons only. And here we did mass number minus atomic number. This was number of protons, and atomic number and protons are equal. They never change. Never, ever. Okay. Let's do another example now. How about, let's do lithium. Look at the periodic table. For lithium, 3 at the top, 6.94 at the top. So here, atomic number. Okay, this is also equals to number of protons, and since it's a neutral atom, is also equals to number of electron. All right, so we are just going to focus on number of electrons at this time. Again, go back to the rule. The rule is 2, 8, 8, 18. How many total electrons we have here? For lithium, the total electrons we have is only 3. We have to distribute these electrons now. So 2 in the K shell, leftover goes to the next one. So it's just 2 and 1. So let's draw the Bohr model. 2, and then we need another shell for that 1 electron. So 2 and 1. 2 and 1. All right. Okay. So this is about the Bohr model. Once again, let me ask you a question. Could it have been 1 and 2? Because 1 plus 2 is still 3. No. Why not? Because again, we have to make sure that the previous shell is completely filled before you go to the next shell. That's why. So you want to make sure you're following the rule of 2, 8, 8, 18. Once again, the rule is applied only for first 20 elements, because after 20 elements, things get trickier, and that we're going to discuss later when we learn about the subshells, SP, DF, and all that. Okay. Now, one more thing. Let me tell you here. You see this number? This number is the valence electron. Okay. So valence electrons are the electrons in the valence shell, meaning the outermost. And this valence electron or electron in the valence shell are equal to the group number on a periodic table for A group elements. For A group elements. All right. And then here, if you go to the periodic table, you're going to see that. I'm going to show you in 1 second here. You see 1 and 2 shells. How many shells you see here? 2 shells. All right. The number of shells, which is energy levels, is equals to the period number for that element. So this shows lithium belongs to period number 2 on a periodic table and group number 1. Okay. All right. So this one, valence electrons, electrons in the outermost shell. Valence means outermost. This was the electron distribution, 2, 1. In for lithium, the total electrons were 3. All right, students. Next one. Let me show you here. I have my notes here for you. Okay, now it's your turn to try for rest of the elements. Just pause the video. All right. Did you try for other elements? Try for calcium? Okay. Okay, great job. I'm happy you tried. Now look here. As you go from left to right, these are the periods. Left to right, left to right, left to right. And I was telling you the number of shells here for hydrogen, it is 1 shell, so 1 period for hydrogen and helium. Second period, everything here, 2 shells. All right, starting from lithium to neon. But remember, even though I'm saying lithium to neon, I'm not including B group element, the transition metals from the middle. This is only for atomic numbers 1 through 20. Okay guys, this does not include transition metals. And the period 3, meaning 3 shells, go from left to right, and period 4 is right here. So the rule of 28818 is only for first 20 elements, but the number of shells will tell you the period number for all of them. And group number is same as valence electrons. All these, 1 valence electron for hydrogen, 1 for lithium, 1 for sodium, 1 for potassium, and same here for group 2 elements, 2 valence electrons, 2 valence electrons, 2 valence electrons for calcium, 2A. But that's not true for transition metals, because transition metals, the valence electrons vary, and that's why we are not including transition metals here. Okay. All right. So it's everything is here. Group is vertical columns, period are horizontal rows. I hope this helps you, and I'll see you guys tomorrow. I'm going to make a Google form and where I'm going to put the multiple choice questions. And you can make up your own questions if you have any more questions. Thank you for watching. Thank you guys. See you tomorrow.